Welcome back. Today we're going to talk about section 4.5, Translations of Conics. The principles that we're going to talk about in this section are not unlike the ones that we've talked about before, and you're going to recognize a lot of the same elements in these equations as we go through, starting on what we built in section 4.4 when we talked about conics, and incorporating some of those things that we talked about when we were translating graphs a couple of chapters ago. So let's go ahead and get started. First of all, you might need to pause and just write these equations down, because what I'm going to do is I'm going to use these equations and kind of show you exactly what's going on in them and what information is given by these equations. So if you need to pause and write these down, go ahead and pause and write them down, but leave yourself a little bit of space below each of them so that you can get those notes that I'm about to give you on each one of them. All right, so you probably just pause to write all these down, and let's look at these equations in depth. First of all, we're looking at a circle. And the circle is not unlike what we've looked at before. The equation is familiar to us. And what we're looking at is an x minus h squared plus y minus k squared equals radius squared. Well, this implies that my center is at h comma k. And so when we look at this equation, that's the information that's given to us by the equation. Okay, so that's, and obviously the radius is r. So that's good information from that equation. Let's go ahead and look at the equation for the parabola. Now the parabola, this is the equation that we're used to looking at. And so I'm going to draw an additional equation underneath here that's going to help you see what this looks like in terms of what we've been talking about with that y squared equals 4px, those sorts of things. If I just rearrange this equation, and you do this algebraically, but I'm just going to go ahead and give you the summary version, we'd have y minus k squared equals 4p times x minus h. Okay, and so you can see the elements are still there. We still have this y, it's still going to be a squared term, and it's still going to have our 4p times x, but it's x minus h. And this x in this, or this h and this k are really important because our vertex is h comma k, and that's going to help us do all those things that we were doing before, where we were looking at the directrix, we were looking at the focus. That's going to give us all those. Additionally, if I rewrite this equation here, I'll have x minus h squared equals 4p times y minus k. Okay, those are the things that we're looking at when we're looking at this parabola. Let's move on to the ellipse. Notice the equation looks somewhat similar. Before we had x squared over a squared plus y squared over b squared, and this h and this k make another appearance. And so we're looking at what the information given by that h and k is. In this case, it's the center. Is h and k. All right, and so yeah, it's the same equation, just with that little additional piece like we had before when we talked about circles, when we've talked about moving parabolas around in the coordinate plane. And so these equations are important because they give us that additional information that we need. The hyperbola. With the hyperbolas, we're also looking at an x minus h squared situation. The same equation that we were starting with when we talked about hyperbolas, just with the addition of the h and the k. And so the hyperbola is going to have a center at h comma k as well. So this h and this k really have a significant role to play here because they're going to tell us a lot of information about what we're looking at. Okay, that's the basics of the equation. So let's look at what we're going to do with this, and notice the key that I want you to remember here is we're always going to need something minus something squared. Okay, and so what we're going to be doing with this is finding different pieces. Let's look at just an equation. Find the center and radius of this. Well, what we see is this is a circle. I've got the x minus 1 squared, y, something squared equals something squared. So this is a circle. And that equation for that circle look at the elements. And so if I'm trying to find the center, that's going to be h comma k. So what am I subtracting in this first one? Well, it's a 1. So my h is a 1. What am I subtracting in the second one? It would be the opposite here. And so my center is 1 comma negative 2. If I'm looking at what my radius is going to be whatever's being squared. So my radius is 3. That's all there is to it. So I'm just giving you a way to look at these things and see some of the elements that are going on here. Equations of conic sections. Notice I don't have anything here because I need to write in this equation for you. And the equation that we're going to be looking at looks like this. It's going to be an x minus 2 squared over 3 squared plus y minus 1 squared over 2 squared equals 1. Well, what we're asking ourselves is what type of shape is this? Well, we notice the plus here, so that makes it an ellipse. And we're looking at, what is the center? And again, I didn't give you any specific instructions. I'm just going through some of these equations with you to let you see what's going on with the way the numbers change and the way that our values change and what that means for our graph in general. So our center is going to be 2, 1, because that's what's being subtracted here. This is my h, this is my k, and what is this other information down here? Well, this would be a and b, and so the horizontal length is 2 times whatever a is, right? Well, an a in this case is 3, and so it's going to be 2 times 3. We're just recognizing the pieces of this equation because we know that it's x over a and then y over a b squared. All right, so my vertical length, my number that goes with my y, y up and down, is going to be 2 times b, so it's going to be 2 times 2 in this case because 2 is what's being squared, so that's going to be equal to 4. Okay, and so this we could sketch an ellipse here, horizontal length of 6. So I could just do a quick sketch right here, and that would be the original ellipse, and the center would be at 2, 1. So I'd move it up to 2, 1, and then each of these would move over. So this moved over 2. So my center is going to be, from the center, go 1, 2, 3, 1, 2, 3. Everything is translated. And my vertical distance is 2, so 1, 2, 1, 2. So this is my translated figure here. I didn't go to art school. Okay, that's what we learned from this. So we can use our lengths to draw our original and then move our center up to give us our translated figure. So this is our figure. That's how we're using this equation. That's how we're looking at this. Another example is going to be x minus 3 squared over 1 squared minus y minus 2 squared over 3 squared equals 1. Well, notice we've got a subtraction problem here, so this is a hyperbola. And our h and our k are going to be 3, 2. Well, what does that mean? That's the center. And what are the other significant portions? So the transverse axis is going to be horizontal in this case because we're subtracting this here. And so the information that we glean from this is, we pull out our values to be able to draw in our asymptotes, and we could sketch this. Notice, this is exactly like what we were doing before. We just now have a new center, and we can find those pieces that give us the information that we need to graph, if the directions were to graph. Again, I'm just showing you what pieces of information are in these equations. All right, so let's go on to an example where we're finding a standard form. So find the vertex and the focus of the parabola in this form. Well, notice, we have been dealing in this form, and I'm going to use x squared because I have an x squared term. X squared equals 4py. Well, the form that we are looking at in this section is like an x minus h squared equals 4py minus k. Well, I don't have any of that information, and I don't have any squares. And so what I need to do is do the general work first. I've got an x on this side, and I've got my y on this side. in my original equation, I have everything on the same side. So what I'm going to do is I'm just going to separate them by moving things over to the other side. So x squared minus 2x equals, and if I moved this, it'd be minus 4y plus 3 minus 4y plus 3 minus 4y plus 3. Why did I do this? Well, it allowed me to have my x squared term on one side, which is what I want to graph, and then my y is on the other side. How did I know what to move? Just strict separation. Okay, now I need to make it look like this. It needs to be a square. So what I'm going to do is I'm going to complete the square. Because I don't have that terms. A square is going to have like that x squared and then an x term and then a constant term. And so this is my b. So I do b over 2 squared, which is negative 1 squared. So I'm going to have x squared, so it's going to be equal to 1, minus 2x plus 1. Well, remember, if I'm going to add that to one side, I got to add it to the other side, equals minus 4y plus 3 plus 1. How did I know what to add? I'm completing the square on this side. Well, now I'm going to rewrite it using this. Okay, so I've got x minus 1 squared. This is equal to this. Like if you FOILed it all out, it would be equal to this. That's what completing the square does for us. And then I've got minus 4y plus 4. Well, notice what I want. I want an x minus h squared on one side. Look what I got. X minus h squared on one side. On this side, I need a 4 times something times y minus k. Well, that means I'm going to factor out a 4. So then I've got negative y plus 4. Well, then I can factor out an additional term, that p. Like, what is my p? Well, I've got a positive y. Here I have a negative y, so it's going to be 4. I factor out a negative 1, y minus 4, x minus 1 squared. So what did I do? I completed the square, and I rewrote it so that I could figure out what my 4p was. So then so I factored the right side to get p here. So this is my p right here. Well, what does that tell me? That tells me that my h is equal to 1. That's this part here. My k is equal to 1. I actually factored this right. You're probably sitting there going, what is he doing? When I factored out this 4, this should have become plus 1. Sorry about that. I factored out a 4. This should have been negative y plus 1. So down here it should be minus 1. You guys are probably thinking I'm crazy. Like, tell me next time. Okay, so my h and my k are 1 and 1. And now my p is negative 1 right here. Well, what does that tell us? That tells me that where my vertex of my parabola is. And it also tells me where my focus is going to be, because it's going to be 1 unit away from my vertex. It also tells me where my directrix is going to be, because p tells us the distance to the directrix. Okay, and so from there we could graph this, all of this. So the focus and the vertex are given in this equation. We just had to do a little bit of work to get there. Okay, so the focus is equal to a point. And the easiest way to do this would be to just do a quick graph of this. So if my h and my k are 1 and 1, I'm going to go to 1 and 1. And if my focus, or if my p is negative 1, then that means my focus is going to be in here. So my graph opens downward like this, and my directrix would be up here. And so my focus is going to be at 1, 0. And I found that by taking, the p, the distance, it goes down 1 from where my vertex is. So my focus is going to be 1, 0, and my center is vertex is 1, 1. Okay, that's how we do that. So we're going to be completing the square sum in this section. Sketching an ellipse. Sketch the graph of the ellipse with this equation. X squared plus 4y squared plus 6x minus 8y plus 9 equals 0. It gets a little bit confusing, but if we're looking at what we need for the equation of an ellipse. Let's just start with our general. X minus h squared over a squared plus y minus k squared over b squared equals 1. So we've got a lot of elements going on here. But first, let's just do this. Let's say to ourselves, okay, how am I going to get my form to look like this? Okay, and notice I've got an x squared term and I've got an x term and I've got its constant. I need to do a little bit of rearrangement. So let's rearrange first. So if I put my terms in order, I'm going to start by taking my constant and putting it on the other side because I know I need to have something on the other side. It's going to have to be a 1. And so I'll just subtract 9 from both sides. So I'm left with x squared plus 6x plus 4y minus 8y equals negative 9. Excuse me. And now I've got two things. This should be squared. I've got two things that I need to complete the square with. I've got to complete the square on my x term. And so I'm going to complete the square. For x and y. So here we go. If I've got my x squared plus 6x, I'm going to look at my b term. I'm going to do 6 over 2 squared, which is 9. So this would be 3 squared. So that's what's going to go in here. So I'm going to end up with an x plus 3, because this is my b over 2 term, squared. And what I ended up adding was 9, and so I'm going to have to add 9 to the other side as well. Okay, so remember, you're doing this to one side. You're completing the square on one side, so you're adding something, so you got to add something to the other side. And then here, I am going to need to have a term in front that's got 1 as its coefficient. So I actually have to factor out a 4 before I complete my square. So I'm keeping track. So now I got to complete the square with the y term. Well, in the y term, this is my b, so I'm going to do a negative 2 over 2, which is, so that's going to be squared, so negative 1 squared. And so my terms are going to look like this, x plus 3 squared plus 4 times, and this is going to be that y minus 1 squared, okay? But what I have to add is, what I added in here, I added a plus 1. Well, it's 4, so this is going to be 4 times plus 1, because what I actually ended up adding in here was a plus 1. So I'm going to add times 4 times 1. And so when you complete that square, you factor out that coefficient, complete the square on the inside, and then multiply by what you factored out. What we've done in the past is we divided both sides, but this is essentially the same thing. And so what I've got here is I have something that looks really kind of familiar here, right? It's starting to look more like this, except I don't have fractions here. I also don't have a 1 over here, so I got to divide both sides by 4. And watch what happens. This is really cool. So I'm going to end up with x plus 3 squared over 4. Oh, look at that. I end up with a fraction. Plus y minus 1 squared. And on the bottom, I'm going to have, well, 4 over 4 is 1, so I'll just have a 1 on bottom, equals 1. I needed it to be equal to 1. This is good. These are good things. Okay, and so what am I looking at here? I'm looking at finding my center so I can sketch my graph. So my center is whatever I'm subtracting from my x term. So my center is going to be 3 because I'm subtracting. It's got to be negative. So it's a negative 3. And whatever I'm subtracting over here is my k, so 1. And so a is the denominator here, so a is equal to whatever's being squared, so my a has to be 2, right? And my b is whatever's on the bottom here being squared, so my b is equal to 1. And so if I go ahead and sketch this, what that's going to give me is a center at negative 3, comma 1. So here's my center. And my major axis, so it's fatty this way, is going to be 2 units to the right and 2 units to the left. My minor axis is going to be 1 unit up and 1 unit down. Darn, I missed. There we go. And that's what it's going to look like. So we have all of our major pieces put in place using the A and the B. The hardest part of this is going to be completing that square, but I'm fully confident that you can do it with a little bit of perseverance, okay? That's the basic gist of working with these equations. Thanks for watching, and we'll see you next time.